Number 4, we are again comparing two different elements, boron and fluorine. So if we look at our chart here, boron is the one here that is in blue. So once again, when we go to do these, we have to find out where the big and the small numbers are. Your big numbers are over here. Your small numbers are over here. So once again, you always want to start with the big numbers. So again, this is 1, 2, 3, 4, 5, and 6 up here. 1, 2, 3, 4, 5, and 6. So you want to start with the big numbers because those are the ones that are closest to the nucleus. So if we go to compare these guys, there's our big numbers. This is going to be 1s2 for the boron. And then the next thing for boron, which is just the blue, this is going to be 2s2. And then this guy here is going to be 2p1, which follows right along with what we see in the periodic table. At the first energy level, or the first shell, we only see 2 electrons, so that's your 1s2. And then at the second energy level that's here, we see 3 electrons, except that they are broken into, there's your second energy level for those guys. They are broken into the 2s2, and then one of those electrons, the fifth one, makes it out to the 2p1 that is there. So for boron, all you get to see here is 1s2, 2s2, 2p, and 1. Now for fluorine, we're going to do the same exact thing, except fluorine is the one that's in pink. So once again, you start with the big numbers. Your big numbers are over here. And the big numbers is always where 1 starts. So this is your 1s2. So that's energy level number 1. Now energy level number 2, that's going to be your 2s2. And then how far up do we get? Let's see, 1, 2, 3, 4, 5, and 6 here. This one is only apparently making it up to about level 5. So that's 2p and 5 here, which again makes sense because here's your first energy level. So that's going to be your 1s2. And then your second energy level here is going to be your 2s2. But then we got to make it all the way to fluorine over here. And so that's going to be 2p, 1, 2, 3, 4, and 5 that's there. So that's going to be 2p5 that's there. So our first step is to label the peaks. Part B says, why is one of the peaks so much bigger than the rest? Well, that's this one here, obviously. Why is that one so much bigger? Well, it has more electrons in it. It is a 2p subshell, and since p subshells can hold up to 6 electrons, the vertical axis on this is the relative number of electrons that's here, as it shows. So that's a very simple answer, that the tall vertical peak on this one has more electrons in it, which